Hello and welcome to my lesson. My name is Zaynab, and today I'm going to be teaching you a little bit of AS chemistry. So it's a small subtopic from the topic atomic structure. The subtopic is called fundamental particles. Now I like to start my lessons with a specification slide. So this is just a screenshot from the AQA specification. I highly recommend that all my students have a copy of an A-level specification where their revision material are, just so that they can keep a track of how far they're in with their content, what they're exactly going through, and also as a checklist for when they revise. So yeah, I highly recommend that. I like to use specifications as a student, and when I'm tutoring, I like to use them as learning objectives. So typically in a lesson, I will use these as learning objectives. I would ask my students to write them down along with the title and the date, and I would read through them. So these learning objectives, the first one is appreciate that knowledge and understanding of atomic structure has evolved over time. The second one says protons, neutrons, and electrons, their relative charge and relative mass. And the third one says an atom consists of a nucleus containing protons and neutrons surrounded by electrons. So that's the specification. The next slide is some starter questions. So these are some GCSE questions. I like to use them to, jog my students' memory and also bring their focus into the lesson as well. So these are some GCSE questions. I also use some questions from, let's say, their previous lesson. That way we make sure that they sort of remember what they're learning, and also we can build up on that knowledge in the the coming lessons. So yeah, I would give them a couple of minutes to go through these questions, and once they're done, I have an answer slide with the answers. We'll go through all the answers together, and any answers that they get incorrect, we will go through their thought process together. That way we can really pin down where exactly it is that they're having this mistake or this misconception, and how they can prevent it in the future as well. Okay, so I don't think we'll have enough time to cover through these slides, so I'm just going to go straight to this slide. So this is about the history of the atom. The slides I've just skipped are about the history of the atom and the different theories over time that scientists have theorized about the atom. We've come straight to Mr. Rutherford. So Rutherford was a scientist in 1911 who conducted an experiment where he passed alpha particles through some gold foil. So alpha particles are essentially positive particles. Okay, just try to think of it as positive particles. And he passed these through some foil, and he found that actually most of the particles passed through, but some of them violently bounced back. Now, if we could just quickly move our thinking to a magnet. So I've horribly drawn, I know, I'm sorry. I've horribly drawn two magnets here. And we've got a positive magnet and we've got a positive magnet. So we've got the positive side of the magnet, We've got the positive side of the magnet facing another positive side of the magnet. So what would happen if two positive magnets were to face each other? They would repel, right? So that's exactly what's happened here. So the positive particles are being repelled by something else positive. And from this finding, Mr. Rutherford drew the theory that most of the mass and the positive charge of the atom is actually at the center of the atom. Okay, what we know as a nucleus now. Okay, and as for the electrons, they're sort of floating in clouds. That's what Mr. Rutherford theorized. Okay, now moving on to the next theory. That's the current atomic model. Okay, so as I've written here, it's similar to the Rutherford model, but just slightly more, it shouldn't have said complex, my mistake, slightly more different. Okay, so we've got the positive nucleus. However, electrons are not floating in clouds in this model. Okay, so the current model we have, the electrons are actually spinning in subshells. Okay, this is a new concept. Okay, so I'm just going to let that sit with you for a second. So I know this isn't exactly the right diagram for an atom. These have missing electrons, but if you just try to remember, during your GCSE times, we have sort of become accustomed to drawing our atoms in this way, where we have the positive nucleus and then we have sort of the negative electrons in these shells, right? Okay, now I'm just going to bring you to the A-level understanding. So instead of having these electrons in shells, we have them in subshells, okay, or sublevels as this table has put it. Okay, so we have 4 different types of subshells. They're called, there's the S subshell, the P subshell, the D subshell, and the F subshell. Now each subshell has orbital levels, or sort of like energy levels, okay? So the S subshell has 1 orbital, the P subshell has 3 orbitals, the D subshell has 5 orbitals, and the F subshell has 7 orbitals. As you can see, as you go S, P, D, F, the number of orbitals increase by 2. And as I've written here, each orbital can have a maximum of 2 electrons. Okay? The shapes, those are, if you're interested, those are the shapes that the orbitals take. They're a bit funky, but thankfully we don't need to know that for our A-level exam. Now, in each subshell, you can have a maximum number of electrons. Okay? So the S subshell can hold a maximum of 2 electrons. The P subshell holds a maximum of 6 electrons. The D subshell holds a maximum of 10 electrons. And the F subshell holds a maximum of 14. Okay? So as you can see here, as we go S, P, D, F, it increases by 4 electrons each time. You can use it as a guide to remember, because this could be tested on in the exam. Well, not particularly tested on, but they could ask you for the electronic configuration, which is something we'll cover in a second. But yes, this is the current atomic model that you're expected to know. Okay, so instead of how we had in the inner subshell in GCSE, let's try and draw it here. The inner subshell, let's say we've got a carbon atom, it has 6 electrons in the inner subshell. We've got 2, which I've again horribly drawn. And then in the outer subshell, we've got 4, and they're in pairs. Yeah? In this is the old GCSE way, right? So this is how we learnt it. It's no longer like that anymore. We've got the first subshell S, then P, then D, then F. Okay? And each of them, they have a maximum number of electrons, and also they have orbitals as well. I know it's confusing, so usually I stop at this point and ask my students if they have any questions or if they'd like me to repeat what I've said. Then we go on to this, electronic configuration. So let's take carbon, for example. So the old GCSE way that we know is the first most inner electron shell holds 2 electrons, the second shell holds 8 electrons, and the third shell holds 8 electrons. So we've got carbon, its atomic number is 6, therefore the number of electrons we have is also 6. So therefore the configuration for carbon would be 2, 4. Yeah? So 2 in the first shell, and then 4 in the second shell. Now in A-level style, we would write this as in the first subshell, so number 1, the S subshell. So we've written the subshell that it is, and then here, sort of like a power, like, you know, squared, we're going to write the number of electrons here. So in the first subshell, it holds a maximum of 2, remember? So now we've got 1s2. As we know, carbon has 6 electrons. So now we've already written 2. 6 minus 2 is 4. So the second subshell, the P subshell, will have 4. Okay, at this point I would stop again for questions, and if not, we would move forward. Let's go here. Then I would give them some questions that they can try it themselves, and again we would go through the answers and clear out any misconceptions. Then finally we'd come back to here and we would tick off everything that we've learnt. Thank you for watching.